Okay, so I've given you a whole bunch of graphs here, so you can slowly copy them down as we're going. So the blue one is the f of x, and I'm going to be drawing the derivative right below it. So here we go. So this point zero at x equals 0 is a corner, so I know the derivative doesn't exist. So if I think of drawing little tangent lines here, they look like they're about a slope 1. So they're constant slope 1 until we get to x equals 0, and I know I cannot find the derivative there at 0, so I'm going to put an open circle, because it's not going to infinity, so this corner turns into an open circle. After the x equals 0, I see there's a constant slope, looks like it's about -1. Oh my goodness, it's kind of that graph, isn't it? So the derivative, so I should be labeling my graphs here. This is the derivative graph, and this is the f of x graph. All right, so here's our f of x graph. So now let's go draw the derivative graph. So this was a graph that had kind of a problem point, right, where the derivative didn't exist. This is nice and smooth, no cusps, corners, endpoints, vertical tangents. I do see there's two places where the slope is 0, right? The slope of the tangent line is 0. So what that translates to, and I'm just going to mark, now you're going to make a number. What that translates to is these two x values, the slope is 0. Remember, because the y-axis here is slope. All right, so I'm going to look at before this number 0, the slope looks like it's positive. So it's a positive slope, and it has to come to 0, right? So big positive, smaller positive, smaller positive. So here's slope 4, 3, 2, 1, right? It's coming down. So the slopes are just decreasing, smaller positive numbers. All right, here the slopes are negative. So I have negative slopes, so below the x-axis means negative slopes, right, on this derivative graph. So I'm just going to have it come down below the x-axis and then join up with this other 0, because I know it gets to a point where slope is 0. Then the slope is positive again. Slope is positive. So it's okay to not to have an exact, you're just getting the curve, and above and below the x-axis. So these are positive slopes, which are above the x-axis, negative slopes, which are below. All right, so this one here, I've tried to really emphasize, this point right here is a vertical tangent. Okay, so what does a vertical tangent mean? So if I have a vertical tangent on my f of x, what that's going to translate to is it's going to give me a vertical asymptote on f prime of x. So wherever that x value is, let's put it right there. So it's going to be a vertical asymptote on the derivative graph. All right, so let's look at what the slopes are doing here. So the slopes are small negative, bigger negative, huge negative to undefined. Small negative to bigger negative to huge negative to undefined. All right, then after that vertical tangent, so then I jump back on the graph, and there's still huge negative, smaller negative, until we get to a place where the slope is 0. So huge negative to smaller to 0 slope, right? 0 slope means at this point here, so it comes from the asymptote and down. So whenever you have an asymptote, it's going to do the asymptote thing, which means it gets really close and it doesn't cross. All right, so then after the slope of 0 gets small, it's positive, 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 and I just drew some kind of positive. So you just have to make it above the x-axis, and it's okay to me, it doesn't matter about filling in the details of exactly how it's the shape of it is, just above and below the x-axis. So here we go. So here's the derivative graph again. So I see a cusp. So a cusp on f of x is going to translate to a vertical asymptote on f prime of x. So let's just even mark that right now. So that x value, no, you need to make the x values. So that's one thing I would put down right away. And then at this point here, it looks like the slope of the tangent line is 0. So let's mark that right there. So those are two huge things. So we're just going to fill in the blanks between. So here I have small positive, bigger positive going to undefined. small positive, bigger positive, going to undefined. Then I've got huge negative, negative slope, less negative, going to 0. So I'm coming from an asymptote, so huge negative means come from down here, going up to this 0 slope, and then after this 0 slope, it's going positive. All right, so here's my f of x again. So this graph here actually has an asymptote, 2 of them. So I just need to put those down, because wherever it's not continuous, right, if f of x is not continuous, then I cannot find the derivative, right? Can't find the slope of a tangent line where the graph doesn't even exist. All right, so here I'm moving small positive, bigger positive to undefined positive, going up to the asymptote. Right after the asymptote, if I jump back on your huge positive to a slope of, oops, I forgot to mark that point there. This looks like it's a slope of 0. So huge positive, right? Huge positive slope. As I'm reading a graph like I'm reading a word. Huge positive to get to a slope of 0. Coming from the asymptote thing, it's going to look like this. All right, so then it's going to get positive slope, so it's still positive, and it's going to go do the asymptote thing and be huge positive again. All right, so after this asymptote, if I jump back on the graph, huge negative, and then it's going to be smaller negative, so huge negative from an asymptote, it's going to come from down here and be smaller negative to here. All right, so this one has a bunch of corners, and we know that corners, or where the graph is not continuous, is not going to have, a derivative. So let's kind of line up the points here. So we've got this point here, and this point, and this point. Okay, so I see this, slopes of the tangent line look like they're 0, and they are 0, and I cannot take the slope of the tangent line at that open circle, correct? This is an endpoint, so I can't find the slope of there, but if I jump back on the graph down here, it's slope of 0 again. So slope of 0, till I get to this corner. So that's an open circle. Then if I jump on the graph, I've got some constant positive slope. So some constant positive slope, can't use the corner, so keep it an open circle, until I get to here. And then it's a corner, so I'm going to put an open circle. And then I jump on the graph again. It's going to be some negative constant slope. And there we are.